Dear students, welcome. This is our 15th class number 15th on hydrostatics. First, let us try to solve this problem. A semi-ellipse bounded by its major axis. Semi-ellipse bounded by its major axis is just immersed in a liquid, the density of which varies as the depth. If the minor axis be in the surface, this is the effective surface, this is the surface. Minor axis is in the surface. Suppose C is the center of the ellipse. B dash CB. This minor axis is in the surface. Eccentricity, in order that the focus may be the center of pressure. Focus lies on the center of pressure. Focus lies on the center of pressure. Along the major axis, this. Along the minor axis, this. Right. Solution. Let C be the center of the ellipse. Let C be the center of the ellipse. C be the center of the ellipse. Let B dash CB, B dash CB, B dash CB be the minor axis of the ellipse. Minor axis of the ellipse. B dash B be the minor axis of the ellipse. The semi-axis is immersed in such a way that the semi-ellipse is immersed in a liquid. Is immersed in a liquid in such a way that the minor axis B dash CB is in the free surface or effective surface. Is in the free surface of the liquid. Free surface of the liquid. Now we take x-axis along. We take x-axis along the major axis. Along the major axis. And the y-axis along the minor axis. Minor axis of the ellipse. Along the minor axis of the ellipse. This is this. Refer to this coordinate axis. Coordinate axis. OX and OY. OX, OY. The equation of the ellipse is x square by a square plus y square by b square equal to 1, where CA equal to A and CB is equal to B. C is equal to A and CB equal to B. C is equal to A, CB equal to B. Right? Now, consider an elementary strip. Suppose PQ is an elementary strip. PQ elementary strip of thickness delta x What is this distance? Is this at the distance x? Consider an elementary strip. Consider an elementary strip. PQ. Consider an elementary strip PQ of thickness delta x at a distance h. At a distance h from the effective surface. From the effective surface means from the y-axis. This is not x or y. Coordinate axis. It is cx and cy. You may write cx and cy. We have written here c is the center of the ellipse. Therefore, you may write cx cy. The equation of the ellipse is this. Consider an elementary strip PQ of thickness delta x at a distance x from the y-axis. So y-axis or the minor axis of the ellipse. This is the minor axis of the ellipse. Minor axis of the ellipse. Now, area of the strip PQ. What will be the area of the strip PQ? Area of the strip PQ. PQ will be equal to twice y delta x. This is the area of the strip. Pressure at any point of PQ. Pressure at any point of PQ will be equal to 0 into this distance from the effective surface is h. Rho is the density. Where rho is the density? Rho is equal to density. And it is given in the question that the density of which varies as the depth. Density varies of the depth. According to the question, density varies as the depth. Now, according to the question, density varies as the depth. According to the question, density varies as the depth. Varies as the depth. This means rho is proportional to x. Means depth. This is the depth x. Rho equal to kx. K equal to constant. K equal to constant. Therefore, density at any point of PQ. Therefore, density at any point of PQ this is equal to G. Rho means kx. Another x. This is equal to G k x square. Thrust on the strip. Therefore, thrust on the strip PQ. Strip PQ equal to pressure into area. This is equal to pressure into area. This is equal to pressure is G k x square into area. Area equal to twice y delta x. Twice y delta x. This is equal to twice G k x square y delta x. Twice zk x square y into delta x. Thrust on the elementary strip. Therefore, thrust on the whole area. Thrust on the whole area. Thrust on the whole area means semi-ellipse. Whole area means semi-ellipse. Thrust on the whole area means semi-ellipse. Thrust on the whole area means semi-ellipse. This is equal to summation twice zk x square y delta x. This. Now you are given that eccentricity and the focus is at the focus may be the center of pressure. Focus may be the center of pressure. Suppose let x bar. First find let x bar be the depth of the center of pressure. Be the depth of the center of pressure. Center of pressure below the effective surface. Below the effective surface. That is the y-axis, or that is the minor axis of the ellipse. That is the minor axis of the ellipse. Therefore, eccentricity, it will have to be found. With the depth of the center of pressure below the effective surface. That is the y-axis. Now, taking moments of the thrust, about y-axis or cy, we get. Moment of the thrust about cy we get. Now, the thrust on the elementary strip was this, twice zk x square y delta x, this. What is the moment of this about this cy? Multiplied by x, multiply this by x, and the sum of the moments will be equal to that. This is equal to moment of the resultant twice zk x square y delta x, and the resultant must pass through the center of pressure. Therefore, it will be x bar. It will be x bar. Now, this means x bar is there. Summation twice zk x cube y delta x divided by summation twice zk x square y delta x. This means x bar will be cancelled. X cube twice zk will be cancelled. X cube y dx. It is x square y dx. X vary from. X may be here and here. 0 to a. It will be 0 to a. X vary. You are integrating with respect to x. X varies from 0 to a. Now, x bar equal to this. Equation of the ellipses. Now, the equation of the ellipses. x square by a square plus y square by b square equal to 1. This means y square by b square. This is equal to 1 minus x square by a square. This means y square is equal to b square by a square into a square minus x square. This means y equal to b by a root over a square minus x square. Root over a square minus x square. Y equal to this. Just substitute the value of y here. X bar equal to this. Therefore, x bar equal from this. You may write it that number 1, therefore 1 implies x bar equal to integration x is equal to 0 to a x cube. Y means b by a root over a square minus x square dx divided by x is equal to 0 to a, it is x square b by a root over a square minus x square dx. Now b by a will be cancelled. Now this means x bar equal to integration 0 to a x cube root over a square minus x square dx integration 0 to a x square root over a square minus x square dx. X square, a square minus x square dx. You will have to integrate this. Very easy integration. Standard substitution. X is equal to a sin theta. Put x is equal to a sin theta. Put x is equal to a sin theta. Dx equal to a cos theta d theta. X equal to 0 implies theta equal to 0. X is equal to a implies theta is equal to pi by 2. X is equal to a implies theta is equal to pi by 2. Therefore, x bar equal to integration theta is equal to 0 to pi by 2. 0 to pi by 2. X cube a cube sin cube theta into root over a square minus a square sin square theta. Dx means a cos theta d theta. Theta is equal to 0 to pi by 2. A square sin square theta root over a square minus a square sin square theta into a cos theta d theta. A cube a to the power 4. You may write here. This is equal to a to the power 4. No, not a to the power 4. This is equal to a cube into from here a, another a square, a and a to the power 5 by a to the power 4. Integration 0 to pi by 2. Sin cube theta. It is cos theta into cos theta, cos square theta, d theta, 0 to pi by 2, sin square theta into cos square theta, sin square theta, cos square theta, d theta. This is equal to a. Obtain the reduction formula 2 minus 1 divided by 3 plus 2, integration 0 to pi by 2. Sin cube theta d theta 2 minus 1 divided by 2 plus 2 0 to pi by 2 integration sin square theta d theta. The reduction formula we have applied this since integration 0 to pi by 2 sin to the power mx cos to the power nx dx equal to, if I denote it by Imn, it will be m minus 1 by m plus n. I am n minus 2. This formula has been applied here. In Buddha integrals, we have applied this formula. Now from this is equal to a. It will be 1 by 5. The integration 0 to pi by 2 sine cube theta 2 divided by 3. Simple integration 2 divided by 3. Here 1 by 4. Obtain the reduction formula. Here also 3 minus 1 divided by 3. 3 minus 1 divided by 3. It is odd. And that integral will be equal to 1. 2 by 3 into 1 equal to 2 by 3. And it is even function 1 by 2 into pi by 2. 1 by 2 pi by 2. 1 by 2 into pi by 2. This way. This is equal to 2 by 15 into 16 by 2. This is equal to 32 by 15 pi. 32 by 15 pi. X bar equal to 32 by 15 pi. 32 by 15 pi. Now, eccentricity is, find the eccentricity. Focus is the center of pressure. Center of pressure and focus is the same point. Center is the, if the center is the, focus may be the center of pressure is on the focus. If the center of pressure is on the focus of the ellipse, then is the focus of the ellipse, then this x bar will be equal to, from the center, the distance of focus from the center will be equal to a into e, will be a into e. Therefore, here a is there, 2 by 15 into a is there, it is 32a. This a, don't forget to write this a, it is a 32a. That is 32a by 15 pi equal to ae. This means the eccentricity will be equal to 32 divided by 15 pi. Therefore, eccentricity of the ellipse is 32 divided by 15 pi. Therefore, eccentricity of the ellipse equal to 32 divided by 15 pi. This is the answer. 32 divided by 15 pi. This is the answer. Here 32 divided by 15 pi. Perhaps you have enjoyed this. Let us take another problem. First, let me remove this. Let us try to solve this problem. What is it? A uniform elliptic lamina whose axes are twice A and twice B is half immersed in water. The axis twice B being in the surface, find the depth of center of pressure below the free surface. Depth of center of pressure below the free surface. The same as the previous problem. Only difference is that in this case the density of the liquid is homogeneous, and in the previous question the density varies as the depth below the effective surface. Therefore, the same diagram will use the same diagram. We will use the same diagram. Let the portion, let C be the center of the elliptic lamina. Same diagram. Let C be the center of the elliptic lamina. Let the portion B dash AB of the elliptic lamina be immersed in water. Immersed in water. In such a way that, in such a way, in such a way that the minor axis B dash CB is in the surface of the water, is in the surface of, in the free surface or effective surface of water, of the liquid means surface of water. This is the case. CA is equal to A, CB equal to B, because twice A and twice B are the length of the major and minor axis of the ellipse. Therefore, CA, we take x-axis along CA and y-axis along CB. We take x-axis. X-axis along the major axis, and y-axis along the minor axis, Now consider an elementary string. PQ of thickness delta x. It is y. Delta x at a distance x from the minor axis, or which is the y axis, at the distance x from the y axis, at the distance x. Therefore, area of the elementary string equal to twice y delta x. Area of the elementary string twice y into delta x. Pressure at any point. On the strip PQ equal to 0 into this distance. From this to this is x distance. 0x. Rho is the density of water. Where rho is the density. In the previous problem, rho we were given that the density varies as the depth. Here the density is constant. The liquid is homogeneous. Rho is the density of water. Homogeneous liquid water. Therefore, thrust, depth of the center of pressure below the free surface. We have to find this one. We have to find depth of the center of pressure below the free surface. We have to find this. Thrust on the strip. Thrust on the elementary strip equal to pressure into area. This is equal to thrust on the elementary strip, pressure into area. What is pressure? 0x into area twice y delta x. This is equal to twice 0xy delta x. Thrust on the strip, elementary strip. Now thrust on the whole area, immersed in the liquid. Thrust on the whole area. means immersed in the liquid. Ellipse, half ellipse immersed in the liquid. Immersed in water. On the whole area will be equal to, this will be summation twice 0 xy delta x. Now in this question, it is not given that the center of pressure is on the focus of the ellipse. In the focus of the ellipse, it is not given. We are to find the depth of the center of pressure below the effective surface. Let x bar be the depth of the center of pressure. Let x bar be the depth of the center of pressure below the effective surface. Let x bar be the depth of the center of pressure below the effective surface. Now taking moments of the thrust about the minor axis of the ellipse, that is about the y-axis. Now taking moments of the thrust. Of the thrust about cy means minor axis of the ellipse, of the elliptic lamina, minor axis of the ellipse. Minor axis of the elliptic. Taking moments of the thrust about cy means, first of all, what is the thrust of the elementary strip? Twice 0 xy delta x. Thrust on the elementary strip. Twice 0 xy delta x. Moment about y-axis is equal to x. Sum of the moments equal to moment of the resultant. This is equal to twice 0 xy delta x. X bar is the depth of the center of pressure below the effective surface. This means x bar equal to summation twice 0, it will be, x square y delta x, it will be twice 0 xy delta x. Twice 0 will be cancelled. This means summation x square y delta x, summation xy delta x. Xy delta x. That's all right. We are to find x bar. Convert it to the integration side. This means x bar equal to integration x square y dx integration xy dx. X equal to, what is the value of x? X minimum value x may vary from 0 to a. 0 to a. X is equal to 0 to a. X equal to 0 to a. 0 to a. Now the ellipsis, suppose it is number 1. The ellipsis x square by a square plus y square by b square equal to 1. This means y square by b square is equal to 1 minus x square by a square. This means y square is equal to b square by a square into a square minus x square. This means y is equal to b by a into under root a square minus x square. You may write like this. Now from 1, you will get x bar equal to integration x is equal to 0 to a x square b by a under root x square minus x square dx integration x is equal to 0 to a x b by a under root x square minus x square dx. b by a will be cancelled, and b by a will be cancelled. Let me write here. This means x bar equal to integration 0 to a x square into root over x square minus x square dx integration 0 to a x root over x square minus x square dx. Very easy integration. To find the integration in the denominator, you may put a square minus x square is equal to z square. This integral can be easily evaluated, is not it? And from this x is equal to a sin theta. Simultaneously, the two integrals can be evaluated by the simple substitution x is equal to a sin theta. Suppose this is number 2. Put x is equal to a sin theta. A sin theta. This means dx equal to a cos theta d theta. X equal to 0 means theta is equal to 0. X is equal to a means theta is equal to pi by 2. X is equal to a means theta is equal to pi by 2. Therefore, from 2 you will get x bar equal to integration theta equal to 0 to pi by 2. X square means a square sin square theta into root over a square minus a square sin square theta, and dx equal to a cos theta d theta. Theta is equal to 0 to pi by 2. X equal to a sin theta into root over a square minus a square sin square theta. Dx is equal to a cos theta d theta. A cos theta d theta. Now, a square a to the power 4. This means x bar equal to a to the power 4. Integration 0 to pi by 2. Sin square theta, it is cos theta, it is cos theta. Sin square theta, cos square theta. Sin square theta, cos square theta, d theta. A cube. 0 to pi by 2. Sin theta, cos theta, cos theta. Sin theta, cos square theta. Sin theta, cos square theta. Sin theta, cos square theta. This one. Very easy integration. This is equal to a. It is nothing but 2 minus 1 divided by 2, 0 to pi by 2 sin square theta d theta. If you put cos theta is equal to z, sin theta d theta is equal to minus dz, minus dz. Therefore, it will be minus z square dz, means integration is z cube by 3. Means cos cube theta by 3. Theta divided by 3. 0 to pi by 2. 0 to pi by 2. It is very easy. And for this integration 0 to pi by 2, we have applied this one. Sin to the power mx, cos to the power nx, dx equal to n minus 1 equal to, suppose this is Imn. This is equal to n minus 1 by m plus n Im, n minus 2. This formula has been applied here in the numerator. This is equal to a. 1 by 4. It is 1 by 2 into pi by 2. And 0 minus 1. It is simply 1 by 3. 1 by 3. This is equal to a pi 16 into 3. This is equal to thrice a pi by 16. Therefore, x bar equal to thrice a pi. X bar equal to thrice a pi by 16. Therefore, center of pressure is at a depth thrice a pi by 16 below the effective surface. Below the surface of the. Therefore, the center of pressure. Therefore, the center of pressure is at a depth thrice a pi by 16 below the surface of the liquid. Surface of the liquid means here it is given this water. Below the surface of water. Center of pressure is at a depth thrice a pi divided by 16 is. Perhaps you have understood this. Very easy integration. Very easy integration. Let us take another. Let us try to solve this problem. The question is a segment of a parabola cut off by a double ordinate. A segment of a parabola cut off by a double ordinate at a distance h from the vertex is immersed with this ordinate in the surface of the liquid. This ordinate in the surface of the liquid. Mn. Suppose I am writing this like this. Suppose O is the vertex of the parabola, Mn is the double ordinate. Surface is the liquid. Find the resultant thrust on it. Find also the position of the point where the line of action, its line of action meets the lamina. This is the O is the vertex. O is the vertex. Suppose this is the x-axis and it is y-axis. Let Mn be the first. Let me write this. Let Mn be the double ordinate of the parabola. Double ordinate of the parabola let Mn be the double ordinate of the parabola. Let Mn be the double ordinate of the parabola. Let O be the vertex of the parabola. Be the vertex of the parabola. Now, the parabola is immersed in such a way that this ordinate Mn is in the effective surface. The parabola is immersed. In the liquid in such a way that the ordinate Mn is in the free surface of the liquid or effective surface, free surface of the liquid. Free surface of the liquid and the vertex. Vertex O downwards. Vertex O of the parabola downwards. Right? Now take x-axis. We take x-axis. Through O. Perpendicular and perpendicular to Mn. perpendicular to a man. We take x-axis through O and perpendicular to a man, and y-axis at the tangent at the vertex O, and y-axis at the tangent at the vertex O. This is the y-axis and this is the x-axis. Right? Also it is given that and the double ordinate is at a distance h from the vertex. H from the vertex means it is given that this distance is h. It is given. This distance is h. Now consider an elementary strip. Suppose consider an elementary strip PQ. P. Suppose it is xy. It is at the distance h. No. At a distance x from y, tangent at the vertex at the take x. Consider an elementary strip PQ of thickness or breadth delta x at the distance x from y. Consider an elementary strip. Strip PQ of thickness or breadth delta x at the distance x from the vertex. At the distance x from the vertex. At the distance x from the vertex. Yes. Clearly, what will be this distance? It will be h minus x. It is x distance and it is given in the question that this distance is h. Therefore, the strip PQ is at a depth h minus x below the effective surface. At a depth h minus x below the effective surface. That's from the vertex. Now, the area of the strip PQ. Strip PQ. It is in the form of a rectangle. This distance is twice y. Y plus y. Twice y. Twice y. Twice y delta x. Twice y delta x. This is the area of the strip PQ. Area of the strip PQ is twice y delta x. Pressure at any point of the strip PQ. Pressure at any point of the strip PQ equal to 0. H distance from the effective surface, it is h minus x. It is h minus x. 0 h minus x. 0 h minus x. Therefore, thrust on the elementary strip. Thrust on the elementary strip. PQ equal to pressure into area. The pressure is 0 H minus H into twice Y delta X. Here you may write rho is the density of the homogeneous liquid. You may write here rho is the density. You may write here rho is the density of the homogeneous liquid. Rho is the density. Density of the homogeneous liquid. Homogeneous liquid. Rho is the density of the homogeneous liquid. Thrust on the elementary strip PQ equal to this. Therefore, resultant thrust on the area. Therefore, total thrust on the area. Total thrust. Thrust on the whole area. Thrust on the elementary area. Thrust on the whole area. Thrust on the whole area. Means the portion MOM. That is the portion MOM. That is thrust on. MOM. The whole portion, this portion, equal to summation 0 H minus X twice Y delta X. This is equal to integration 0 2 times of H minus X Y dx. What is X vary from? X may vary from this 0 to H. X vary from 0 to H. 0 to H. Very simple, very simple. X vary from 0 to H. This is the thrust. We have to find out the resultant thrust. That is the resultant thrust. This is the resultant thrust. Thus integrate this resultant thrust. Let me. Therefore, resultant thrust equal to twice 0 to H, H minus X, Y. Replace it by H. What is the relation? Equation of a parabola y square is equal to 4ax. Y square is equal to 4ax. Root over 4ax. The parabola is y square is equal to 4ax. The parabola is. Y square is equal to 4ax. The parabola is y square is equal to 4ax. This is equal to twice 0, 2 times of root over a, integration 0 to h, h minus x, it is root over x means x to the power half dx. This is equal to 4, 0, root over a. It is h, x to the power 3 by 2 divided by 3 by 2 minus x cube. The integration of x cube is x to the power 5 by 5. X to the power 3 by 2, x to the power 5 by 2 divided by 5 by 2. 0 to h, 0 to h. This is the integration. h into x by 2. X to the power half. X to the power half. The integration of x to the power half. X to the power 3 by 2 divided by 3 by 2. X into x to the power half means x to the power 3 by 2. The integration of x to the power 3 by 2 is x to the power 5 by 2 divided by 5 by 2. And limit is 0 to h. This is equal to 4, 0. Root over a. 2 by 3. H to h. Put here h. H to the power 3 by 2 into h. H to the power 5 by 2. Minus 2 by 5. to the power 5 by 2. I am this is root A. H to the power 5 by 2. 2 by 3 minus 2 by 5. 2 by 3 minus 2 by 5. This is equal to 4 rho root over A into H square into root over H. You may write like this. H to the power 5 by 2 means H square into root over H. Into 2, 15, 5 minus 3. You may write like this. 15 into 5 minus 3. This is equal to 4 rho H square root over AH. 2 into 2, 4 by 15. 4 by 15. 2 into 2, 4 by 15. This is equal to 4 rho H square. No, 4 not 4 into 4, 16 by 15. 16 by 15, 0 H square. Root over AH. This is the resultant thrust. Resultant thrust. 16 by 15. This is the resultant thrust. This is one answer. And find the resultant thrust on it. Find also the position of the point where each line of action means the line of action of the resultant thrust meets the lamina. By definition of center of pressure, the resultant thrust passes through a point. That point is called the center of pressure. The point at which the resultant thrust acts on it is called the center of pressure. We have to find indirectly we are asked to find the center of pressure of this lamina. We are asked to find the center of pressure of the lamina. Just find the center of pressure. Depth of the center of pressure below the effective surface. Depth of the center of pressure below the effective surface. Now, depth of the center of pressure. Let x bar be the depth of the center of pressure. CP means center of pressure. From the vertex of the parabola. Right? From the vertex of the parabola. Let x bar be the depth of the center of pressure from the vertex of the parabola. From the vertex of the parabola. From this point, O point, we will find x bar, the distance from the y-axis. This distance will be evaluated. As soon as we evaluate x bar, means the distance of the center of pressure from the vertex. Then the position, the center of pressure from the effective surface will be equal to h minus x bar. H minus x bar, it will be the depth of the center of pressure below the effective surface. You will have to calculate h minus x bar. Now, x bar be the depth of the center of pressure from the vertex of the parabola. From the vertex of the parabola. Depth of the center of pressure from the vertex of the parabola. Now, taking moments of the thrust taking moments of the thrust about OY we get now moment of the elementary strip about OY you find what is the pressure of the elementary strip? G rho into H minus X. The area is twice Y delta X. It is the thrust on this. Moment will be just multiplied by X. This is equal to, put it here, summation 0 H minus X twice Y delta X into X bar. This means X bar equal to summation twice 0 H minus X HY delta X divided by summation twice 0 H minus X Y delta X H minus X Y delta X. This is equal to summation H minus X X square Y not X square Y XY delta X summation H minus X Y delta X. This is X bar. Y equal to just convert it to the integration. From this I am writing here. This means X bar equal to integration H minus X XY dx integration H minus X Y dx. X equal to 0 to H. The limit should be 0 to H. 0 to H. X should be equal to 0 to H. This is the equation. 0 to H. This means X bar equal to integration 0 to H. X equal to 0 to H. H minus X into X. Y equal to root over 4AX dx. X is equal to 0 to H. H minus X. Y means root over 4AX dx. Root over 4A, root over 4A will be cancelled. This is equal to X minus 0 to H. H minus X. X to the power 3 by 2. 0 to H. H minus X. X to the power half. This dx. X minus. This is equal to H X to the power 5 by 2 divided by 5 by 2 minus, it is X to the power 5 by 2, the integration of this, X to the power 7 by 2 divided by 7 by 2, 0 to H. It is H X to the power half, X to the power 3 by 2 divided by 3 by 2 minus X to the power 3 by 2, X to the power 5 by 2 divided by 5 by 2 after integration. You will get this. Integration, you will get this. It will be, you know, H to the power 5 by 2 into H. H to the power 7 by 2, H to the power 7 by 2. If you put 0, it will be 0. and therefore from the numerator you will get h to the power 7 by 2. H to the power 7 by 2. It will be 2 by 5 minus 2 by 7. It is h to the power 5 by 2. 2 by 3 minus 2 by 5. 2 by 3 minus 2 by 5. Two by 3 minus 2 by 5. This is equal to h to the power 7 by 2 minus 5 by 2. 2 will be cancelled. 5 into 7, 7 minus 5, 3 into 5, 5 minus 3. This is equal to h 2 by 35, 15 by 2. 2 will be cancelled. This is equal to 5. Thrice h by 7. Thrice h by 7. You will get thrice h by 7. Therefore, the depth of center of pressure from the vertex of the parabola is thrice h by 7. Therefore, depth of center of pressure from the vertex O of the parabola equal to thrice h divided by 7. Therefore, depth of the center of pressure below the effective surface will be h minus this. H minus this. Therefore, depth of the center of pressure below the effective surface equal to h minus thrice h by 7 equal to 4h by 7. This is that. Below the vertex is thrice h by 7 and below the effective surface depth of the center of pressure is 4h divided by 7. Right? I hope you have enjoyed this. Now let us take another one. Let us try to solve this problem. What is it? A quadrant of a circle of radius A is immersed vertically with its bounding radius horizontal at a depth B. Find the center of pressure. Suppose this is the L dash L. Be the free surface of the liquid. It is completely immersed. OAB is the liquid, it is completely immersed. We take x-axis and y-axis in this direction. Also, it is given that it is at a depth B. Here to here, it is B. A quadrant of radius is immersed vertically with its bounding radius horizontal at a depth B. It is at a depth B. This distance is B. Suppose it is a R delta theta delta R. Elementary area at the point P. Polar coordinates is r theta. Refer to OS pole and OX as initial line. And then this distance will be equal to r sin theta. Definitely this distance will be r sin theta, and if you write it, this distance will be equal to r cos theta. Simple. This distance will be r cos theta and this distance will be r sin theta. Let me write. This is the question. Let L dash L be the effective surface of the liquid. The quadrant OAB of the circle of radius A be immersed in the liquid such that in such a way that the bounding radius OA OA is horizontal. Bounding radius OA is horizontal. That the bounding radius OA is horizontal. And OB is vertical. We take x-axis along OA and y-axis along OB. We take x-axis. Along OA and y-axis. Along OB. Y-axis along OB. Right? Now, consider an elementary area. R delta theta delta R at a point P whose polar coordinates are r theta referred to O as pole and OX as initial line. Referred to O as pole and OX as initial line. Right? Now pressure at P. Pressure at P is equal to 0 into this distance. What is this distance from the effective surface? It is r sin theta plus B plus r sin theta. The vertical distance of this below the effective surface, this B plus r sin theta. Therefore, thrust on the elementary area R delta theta delta R will be equal to 0 B plus R sin theta R delta theta delta R. Thrust on the elementary area R delta theta delta R equal to 0 this into R delta theta delta R. Therefore, thrust on the whole area, means the quadrant, will be equal to summation. Therefore, thrust on the whole area. That is the quadrant OAB of the circle. The quadrant OAB of the circle. will be equal to double summation 0 b plus r sin theta into r delta theta delta r. Thrust on the whole area will be equal to this. Thrust on the whole area will be equal to this. Now let C x bar y bar be the coordinates of the center of pressure. Be the coordinates of the center of pressure. Of the center of pressure of the quadrant of the area referred to the coordinate axis OX and OY. Refer to the coordinate axis OX and OY. Let x bar y bar is the coordinates of the center of pressure. Now, as usual, we have written everything. Find the center of pressure. Yes, remove this. Now, taking moments on the thrust, taking moments of the thrust, about OY, you will get x bar. Taking moments of the thrust about OX, you will get y bar. Taking moments of the thrust about OY, moments of the thrust about OY, you see here 0 b plus r sin theta r delta theta delta r into about OY, it will be r cos theta, put double summation. This is equal to double summation 0 b plus r sin theta r delta theta delta r. It will be x bar, x coordinate of the center of pressure, moment of the resultant thrust. Resultant thrust pass through the center of pressure. Therefore, resultant pressure about this, it is distance will be x bar. This means x bar equal to 0 will be cancelled. You may write b plus r sin theta into r square cos theta delta r b plus r sin theta into r delta theta delta r. R delta theta delta r. Right. Now convert it to the integration. This means x bar equal to integration r equal to 0 to a theta is equal to 0 to pi by 2 b plus r sin theta into r square cos theta d theta dr. Here r equal to 0 to a, theta is equal to 0 to pi by 2 b plus r sin theta into r d theta dr. R d theta dr. Or x bar equal to, you may write x bar equal to integration 0 to pi by 2 b cos theta, b cos theta are equal to 0 to a r square dr d theta, this one integration, and the other is plus 0 to pi by 2 sin theta cos theta, sin theta cos theta r equal to 0 to a r square into r, it will be r cube dr d theta, it will be this. And in the denominator, you see in the denominator theta equal to 0 to pi by 2 b r equal to 0 to a r dr d theta plus integration 0 to pi by 2 sin theta into integration 0 to pi by 2 r square dr d theta. You will get this. You will get this one. This will be applied later on, therefore I am not going to do this. From this I am writing here. This is equal to, you know, b can be taken outside, integration 0 to pi by 2, it will r cube by 3 means a cube by 3, a cube by 3 cos theta d theta plus, it is again a to the power 4 by 4, a to the power 4 by 4, a to the power 4 by 4, 0 to pi by 2 sin theta cos theta d theta, it is b a square by 2 0 to pi by 2 d theta plus 0 to pi by 2, and it is a cube by 3. No, it is a 0 to pi, 0 to a. 0, a cube by 3, a cube by 3, 0 to pi by 2. Sin theta d theta, sin theta d theta. This. Now, this means x bar equal to, what is it? A cube b by 3, it is sin theta 0 to pi by 2, 0 to pi by 2, a to the power 4 by 4, it is sin square theta divided by 2, 0 to pi by 2, a square b, a square b by 2, it is pi by 2, it is theta 0 to pi by 2 means pi by 2, plus a cube by 3, a cube by 2, a cube by 2, not 3, a cube, it is a cube by 3, because if you integrate r square, it will be r cube by 3, a cube by 3, a cube by 3, a cube by 3, it is minus cos theta 0 to pi by 2, 0 to pi by 2, this is equal to a cube b by 3 into 1 plus a to the power 4 by 8 into 1 divided by a square b pi by 4 plus a cube by 3 minus 0 plus 1. minus 0 plus 1. Now, this is equal to a cube by 24 common. It will be 8b plus thrice a cube by 3. A cube by 12 common. A cube by 12. Not a cube by 12. A square by 12 common. Thrice AB pi. No, thrice B pi. A square by 12. Thrice B pi. Plus 4a. 4a. This is equal to. This means x bar equal to a by 2. A into thrice a plus 8b 2 times of 4a plus thrice b pi. X bar is equal to this. One answer we have found. One answer. A into thrice a plus 8b divided by 2 times of 4a plus thrice b pi. Now, similarly, taking moments of the thrust about OX we gave. Taking moments of the thrust about OX we gave. About OX we gave. 0 B plus R sin theta R delta theta delta R, it is the thrust at a point P. About OX, it will be R sin theta. It will be R sin theta. And put it double integration. This is equal to moment of the resultant 0 B plus R sin theta into R delta theta delta R into Y bar. This into Y bar. Right? Into Y bar. Now Y bar equal to put double summation 0 B plus R sin theta R square sin theta delta theta delta R divided by this double summation GR B plus R sin theta R delta theta delta R. Y bar equal to this. Anything mistake? A square B by the 4. Now Y bar is equal to this. 0 0 will be cancelled like this. This means Y bar equal to double summation. First integration 0 to theta is equal to 0 to pi by 2. 0 to pi by 2. B sin theta. You write B sin theta. R equal to 0 to A. It will be R square dr. And it is d theta plus integration theta is equal to 0 to pi by 2 sin square theta r equal to 0 to a, r is equal to 0 to a, sin square theta r is equal to 0 to r cube, r square into r cube, dr d theta divided by integration theta is equal to 0 to pi by 2 b r equal to 0 to a, r dr d theta, plus integration 0 to pi by 2, it is sin theta, r equal to 0 to a, r into r, you see r into r square dr d theta, very simple. Just integrate this. This means y bar equal to. It is r cube by 3 means a cube by 3. A cube b by 3. Sin theta d theta. The integration is minus cos theta. 0 to pi by 2. Simple. Plus. It is a to the power 4 by 4. Integration sin square theta 0 to pi by 2 sin square theta. You may apply reduction formula here. Now it is b a square by 2. It is theta 0 to pi by 2 plus a cube by 3. This is a cube by 3. Sin theta, it is minus cos theta 0 to pi by 2. Yes, you are done. Right? This means y bar equal to a cube b by 3. It is 0 minus 0 plus 1 plus a to the power 4 by 4. It is 1 by 2 into pi by 2. It is a square b by 2 into it is pi by 2 plus a cube by 3 minus 0 plus 1. This means y bar equal to a cube b by 3 plus a to the power 4 pi divided by 16 a square b pi by 4 plus a cube by 3. This is equal to, you may write a cube by 48 among 16b plus thrice pi 8 divided by, you may write here 12 a square by 12 among thrice b pi plus a into 4 a. This means y bar equal to a divided by 4 into, it will be thrice a pi plus 16b divided by 4a plus thrice b pi. Y bar is equal to this. This means y bar is equal to this. Right? Thus we have got x bar equal to A into thrice A plus 8B divided by 2 into 4A plus thrice B pi, and y bar equal to A into thrice A pi plus 16B divided by 4 into 4A plus thrice B pi. Thrice B pi. This is the answer. Therefore, this is the coordinates of the center of pressure of the quadrant emerged in the liquid, such that one radius is horizontal and this radius is at a depth B below the effective surface. Then the center of pressure is given by this. Dear students, I want to stop here. Thanks for attending the class. Thank you very much. Thank you.